Okay, we already know how to do scatter plots, but why not do them more? And we're also going to talk about correlation, relationship between X and Y, and something called regression. All right, get my colors. So first of all, we know how to make a scatter plot. We've done this before. We know how to plot points. So for instance, we have to make a scatter plot on this data. It's time spent on Clash Royale versus your math mark. So I'm going to take each point at 1 hour. So I've already made a grid here, and maybe I shouldn't have, because this is probably the hardest part of a scatter plot. It's to create the grid. So I want to put time spent on Clash on the X and the math mark on the Y, because this is the independent variable. So what that means is, which one matters first? It's like, think of it this way. The more you spend time playing Clash Royale, does that affect your class mark? Or does your class mark affect the time spent on Clash Royale? That doesn't work that way. It only works one way. So I put the independent variable here. Time is usually always independent. You can't really affect time. And your math mark's here. So I'm going to plot all these points as accurately as I can. Tough without a grid. That's my first point. That's 1 in 83. 2 in 78 is right here. 3 in 67. I got to face it. 4 in 60. 5 in 57. 6 in 52. 7 and 41, and 8 and 37. Okay, I also want to show you. Okay, I forgot to mention that because I'm not starting at 0 here, like I don't want to go from 0 to 30 because it takes a long time. As long as there's no more data points from 0 to 30, I can draw a little lightning bolt there to say, don't worry about 0 to 30. There's nothing there for me to consider, so I can just start at 30 and go up to 100. Okay, so I plotted my points. I'm done. I can draw a line of best fit. We're going to be doing that a lot today. But let's answer these questions. Is the relationship positive or negative? So it's really easy to figure out if a relationship is positive or negative because we already know slope. The slope here is negative. So if I want to draw a line of best fit, I'll do my best. There's my line of best fit. Okay? Can't be 100% accurate for everyone. Only a computer can be 100% accurate. But I do my best to go through the data. Maybe an equal amount of points are on the top and the bottom, and it should model the pattern as best as possible. Is the relationship positive or negative? Well, it's negative because the slope is negative. So this is a negative relationship. Is the relationship strong or weak? Okay, this is something that's kind of subjective based on like your scale, to be honest. If I scale this in, those points are going to be further away from the line. So strength is how close points are to the line. If points are far away from the line, it's weak. This is a very strong relationship. Look at that line, it goes almost through every single point. So this is strong. Okay, and we'll talk more about the strength on the next side over here. Draw a line of best fit and estimate the mark of someone with 0 hours of Clash Royale. So I drew my line of best fit, but I didn't go all the way to 0. So I'm going to make sure that my line goes all the way to 0. And now I can estimate right here, maybe that's 87. So someone who plays 0 hours of Clash, I'm going to estimate that they're going to get an 87% in math. Okay? Doesn't mean they're going to get an 87, right? Just that's based on the data that I've acquired of these few points. I can make that assumption. Okay, even if I have to pick 6 hours, I'm going to assume that that person's probably going to get a 50, just based on my line. Okay, the line helps me understand where the data is. Okay, so let's talk about correlation. There's a word that is always going to come up. It has 2 properties. Either it's positive or negative, okay? Or is it strong or weak? So these few examples will help us understand what that means. So for instance, it's definitely positive because it's going up to the right, like a positive slope. So it's positive. But the grouping is tight, so it's also strong. Whereas this one is negative, but you can tell, like, is it negative? Yeah, because it's kind of weak negative. It's not that strong. because the grouping is spread. So this is negative, but weak. Look here, I don't even know how to draw a line through this. It is possible that there's actually no correlation. It's like saying color of car versus type of music. It doesn't have to be a correlation between any two variables, right? It can be no correlation. There's no relationship between those. So no correlation is possible. Let's do two more. This is also positive, but it's weak. And look at that one. That one is as strong as it gets. Look at those points. They're lined up perfectly. If I drew a line through those points, I can almost hit every single point. So this is negative and strong. I don't have to say very strong. We're going to say how strong in the next point to understand regression. So when we use statistical analysis to quantify a relationship, so usually you do scatter plots like on Excel or Google Sheets or some sort of computer. And actually the computer does all the work for you. It draws the line for you and it tells you how strong the relationship is, which is amazing. You don't only have to do it. This is called linear regression. It's how far away the points are from the trend line. Look how far these points are from the trend line. I'm actually going to draw like a little line to connect them to the trend line. But look at this weak relationship. If I draw a trend line here to show this negative relationship, look how far away the points are from the trend line. So the further away points are from this trend line, that's what makes it weak. But when they're tight, it's strong. So that's what linear regression models. You don't have to calculate linear regression. You just have to understand what it is. Because you can't calculate, well, you could, but not at this level. So when you get a plot and Excel or Google Sheets gives you a trend line that you can just select trend line on, it'll give you a regression number. And this is called an R value. It just gives you a number between -1 and 1. This is 100% strength. This is negative 100% strength. It has to do with kind of the slope. So you have to know that if you have an R value of 0.9, that's strong. That's all you really have to know. Okay, so if I give you this line and it gives you the equation of the line y equals mx plus b, and it says R equals negative 0.6. You have to know that, well, negative 0.6, that's kind of a moderate to weak correlation. Also, because it's negative, I know that it's negative, but I can also look at the lines to determine that. It's really easy. Okay, so R values have to do with strength of the relationship. Yeah, I can say strong, but to say like R equals 0.9, that actually tells me exactly how strong it is. If I go over here and say R is 0.99, wow, that's a very strong relationship. Okay, that means if I'm going to estimate a point, like 0 hours spent, it's almost guaranteed to be like true. But if the R value is like 0.6, yeah, I can estimate outside of the data, but it's not going to be like 100% accurate. Okay, and that's it. It's really, I mean, we know how to plot points. We know how to draw a line through points. We just have to understand these things. Okay, and also over here, the relationship positive or negative, there's also something else you should be able to say over here, and it's like describe the relationship. I always say, as X increases, so as time spent on Clash increases, okay, so if you're ever describing the relationship, you always say whatever the X is first, increases. As this increases, what happens to the Y? Math mark decreases. So this is the actual only word that should change anytime you're writing a description. It's like as whatever this word increases, this word, it either decreases or it increases. There's only two options. Okay? And as soon as I see decreases, I know this is negative correlation, even without a graph. So if I'm given these words, this increases, this decreases, negative correlation. This increases, positive correlation. And that's it for scatter plots and regression.